In this video, we're talking about the components of a program, a C program, and the building blocks that make up that program, so the anatomy of the program. And we have different levels of building block. At the top level is the program itself. We call that the unit of execution. That's what we're going to run on the computer system when the program is built and ready to run. The program is built out of a collection of functions. The function is a unit of organization. So it's our module, like a subroutine in an LC3 program. A function is built out of statements. A statement is the unit of work. So we execute one statement in our program, and then we move to the next statement and execute it. We do that work, and we move and we do the work of the next section, of the next statement. So the statement is our unit of work, and then our expression is a way to express or describe a value in the program. So statements are built out of expressions, functions are built out of statements, and programs are built out of functions. So for an analogy, the way we write English prose, we think about an essay as the product that we're trying to write. Our unit of organization is the paragraph. So a function is similar to a paragraph. It's one cohesive thought, one cohesive computation that we want to do as part of building up our program. Paragraphs are built out of sentences, right? So a sentence is one independent thought. So we read a sentence and then we read the next sentence. So that's like a statement in a C program. And finally, the expression is the words that we use to build up the statement. So we're going to talk about each of these things from the bottom up. So we start with an expression. An expression is something that represents a value in the program. So it might be just a literal value, the number 13, the letter B, the number 9.7. So we write a specific constant value in our program. That is an expression. Or it might be a variable. A variable is a placeholder for a certain type of value. So the variable x might be something that holds an integer value. So it represents a storage location in the computer, and that storage location can hold a value. And so that is an expression. NumWidgets is also a variable name. An expression might be a function call. We're going to talk about function calls a little bit later, but just to show you an example of this is the result of calling the min function with the parameters x and 13. So this whole thing represents a value, which is the minimum of the value of x and the value of 13, and that itself is an expression. And then we combine these types of values with operators to form more complex expressions. So x is an expression, 3 is an expression. We combine them with the plus operator to get a new expression, x plus 3. Operator, 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 expression, expression, expression. This is an expression that represents the division of n divided by y plus the value 4.7. And we take that whole expression and apply the negation operator to it. So you don't have to understand this yet. This is just showing you that any number of expressions can be combined into a larger expression using operators. So if an expression is a value, then a statement is a piece of work that we need the program to do. The simplest statement is an expression followed by a semicolon. It's the semicolon that makes it a statement. A equals 3 by itself is an expression. A is a variable, 3 is a literal value, and equals is an operator. So this is an expression. When we put the semicolon after it, that makes it a statement. So that makes this a piece of work that needs to be performed before we move on to something else. If we want to combine multiple statements into one logical statement, we can do that by putting these curly braces around it. So here we have a statement A equals 3, semicolon, another statement B equals A, semicolon, and we put braces around that. So from a program's point of view, this can be treated as a single statement that's made up of multiple statements, like a compound statement in English. I like ice cream and I like waffle cones, right? So that's one statement with two independent thoughts in it. Then we have other types of statements that we can build that we'll learn over time, and this is an example of an if statement where we have literally if, parentheses, and we have an expression, and we look at the value of that expression to decide if it's true, and if it's true, then we execute this statement. So we'll talk about these. These are special kinds of statements that we can build, and our functions are built out of sequences of these statements. So a function is like a subroutine. It's our unit of modularization, our unit of organization. So a function is a sequence of statements that usually returns a value. It's not required to return a value. But here's a very simple function. Again, you don't have to understand the details of this. We'll talk about functions a lot. But this is a function, the definition of a function called add2. It returns an integer value. It takes in an integer value that we'll call x. And so what it does, the purpose of this function is to take in a value x, compute this value, x plus 2, and return it to the column. Okay, that's what this function does. To make that happen, we do a function call. So somewhere it's in the program, we call add2 with some value here. A value is an expression, so any expression can be in these parentheses here. So we're computing the value n divided by 6. We're giving it to the add2 function. We're adding 2 to it, and that returns a value here. So this is an expression, operator, expression, operator. Semicolon makes it a statement. So this is a statement that calls the add2 function with the value that we get from dividing n by 6. We add the result to 100, and we assign that result to the variable num. This is an example of a function call. So we create functions and we call functions in order to execute them the same way that we call subroutines in an LC3 program. So a C program is a collection of functions. It must have at least one function, and that function must be named main. So there must be a main function in the program. And when the program starts, the main function gets called. So that's what starts the program off. And if main calls another function, we go to that function and execute those statements, and that can call another function, and so on. So that's why we have at least one function called main, and we might have many functions in our program.